Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and in this session we are going to find out the domain of this function f of x, that is equal to square root of pi by 3 minus sine inverse 3x, right? So here, in order to get the domain of this function, we'll make use of some concept from inverse trigonometric function. And here we'll first consider the range of sine inverse function. So let us start. So now from inverse trigonometric functions, we know that the range of sine inverse theta belongs to this interval, that is minus pi by 2 to pi by 2, where minus pi by 2 and pi by 2 both the numbers are included. And we can also write it as sine inverse theta greater than or equal to minus pi by 2 but less than or equal to pi by 2, and provided this theta belongs to this interval minus 1 to 1, that is theta greater than or equal to minus 1 but less than 1. So this is the information we have from inverse trigonometric functions, right? So here we have a sine inverse 3x, and we have the square root sign. So in order to get the domain of this function, the first condition is that this quantity which is under the square root sign, it must be greater than or equal to 0. That is pi over 3 minus sine inverse 3x should be greater than or equal to 0, or in other words, this quantity must be positive or 0. So now we can also write this inequality as minus sine inverse 3x greater than or equal to minus pi by 3, taking pi by 3 to the right hand side. Now cancelling the negative signs, we have sine inverse 3x less than or equal to pi by 3. So when we cancel these two negative signs, then the direction of the inequality, it gets reversed, right? Okay, so now here we have sine inverse theta greater than or equal to minus pi by 2 but less than or equal to pi by 2. So if we take theta is equal to 3x, then for sine inverse 3x, we can now write sine inverse 3x is greater than or equal to minus pi by 2 but less than or equal to pi by 2. So here we have minus pi by 2, and here we have pi by 2. So according to this definition, sine inverse 3x should be greater than or equal to minus pi by 2 but less than or equal to pi by 2. But from this inequality, we have sine inverse 3x should be less than or equal to pi by 3. Now pi by 3 is 60 degrees, right? And pi by 3, it lies between minus pi by 2 and pi by 2. So pi by 3, it lies somewhere here. And sine inverse 3x less than or equal to pi by 3 indicates that we have this region, right? Because sine inverse 3x cannot be less than minus pi by 2. That is, the sine inverse 3x cannot go beyond minus pi by 2 to the left of minus pi by 2. And similarly here, sine inverse 3x cannot exceed beyond pi by 3 towards the right of pi by 3. So sine inverse 3x has to lie between minus pi by 2 and pi by 3. So we can now write sine inverse 3x greater than or equal to minus pi by 2 but less than or equal to pi by 3. So now from this inequality, we have to find out the interval for x. So now taking the sign of all these three quantities, that is we can take sign of minus pi by 2, then we have sign of sine inverse 3x, and here we have sine pi by 3. So what we have done here, in order to remove this sine inverse, we have taken the sine of all these three quantities. So here we have sine of minus pi by 2. So sine of minus pi by 2 is minus sine pi by 2, that is minus 1. Sine 90 is 1, and here we have used this result, that is sine of minus theta is equal to minus sine theta. So here we have minus 1, and here from inverse trigonometric functions we have this property, that is sine of sine inverse say theta is equal to theta. So here we have 3x for theta. So this quantity is now simply 3x, and here sine pi by 3. So sine pi by 3 is sine 60 degrees, that is square root of 3 over 2. So now dividing throughout by 3, we have minus 1 over 3, and here we have 3x over 3, and here we have root 3 over 3 times 2. So we can now write minus 1 over 3. Here 3 and 3 get cancelled, and here we have root 3 over 6. So x lies between minus 1 over 3 and root 3 over 6, including both these extreme points, right? So the domain of this function is given by x belonging to this interval, that is minus 1 over 3 to root 3 over 6. Hello viewers, in today's session we are going to discuss an important conceptual problem from a domain of functions involving inverse trigonometric functions. So here we have to find out the domain of this function f of x, that is equal to square root of sine inverse 2x, right? So this is an easy problem, and here we have to just make use of the range of sine inverse function, right, or the principal value branch of inverse sine function. So let us start. So now from inverse trigonometric functions, we know that sine inverse theta has the range, that is from minus pi by 2 to pi by 2, provided this theta belongs to minus 1 to 1. So here we have sine inverse theta greater than or equal to minus pi by 2, and here we have pi by 2, and here we can write theta greater than or equal to minus 1 but less than or equal to 1. So this concept will use while finding out the domain of this function. So here we have square root of sine inverse 2x, right? So the first condition is that under this square root sign we cannot have a negative number. So sine inverse 2x has to be greater than or equal to 0, because if we have a negative number inside this square root sign, then it becomes a complex number, and here we are dealing with only real numbers, right? So sine inverse 2x should be greater than or equal to 0. So now from this inequality, if we take theta is equal to 2x, then this inequality indicates that sine inverse 2x should be greater than or equal to minus pi by 2, and here we have pi by 2. and here we should have this 2x uh, greater than or equal to minus 1 but less than or equal to 1. So now here we have minus pi by 2, and here we have pi by 2, right? And between minus pi by 2 and pi by 2 we have 0. Now see, from this inequality, that is from the range of sine inverse function, this inequality says that sine inverse 2x should be greater than or equal to minus pi by 2 but less than or equal to pi by 2, provided 2x is greater than or equal to minus 1 but less than or equal to 1, right? But here sine inverse 2x should be greater than or equal to 0. So we have to consider sine inverse 2x only in this interval, including 0, right? And all the values of sine inverse 2x which lies in this interval, that is minus pi by 2 to 0, are not allowed, right? So these are not allowed because here sine inverse 2x is negative, that is in this interval which is closed from the left and open from the right. So all the values of sine inverse 2x which lies within this interval are negative, right? But here we have to take sine inverse 2x greater than or equal to 0. So sine inverse 2x should be either 0 or it should be a positive. So we have to discard this interval, that is minus pi by 2 to 0. So all the values of sine inverse 2x lying in this interval should be discarded or not allowed, and we are allowed to take only this interval, that is values of sine inverse 2x which lies in this interval, that is from 0 to pi by 2. So here we have the allowed interval, that is 0 to pi by 2. So now we have to write here sine inverse 2x should be greater than or equal to 0 as required by this condition, and because sine inverse 2x cannot go beyond pi by 2, so here we have less than or equal to pi by 2, right? So this inequality is incorporated in this inequality. So sine inverse 2x should be greater than or equal to 0 but less than or equal to pi by 2. So now sine inverse 2x is positive in this interval, that is 0 to pi by 2. So now we have to get the values of x from this inequality. So now taking the sign of all these three quantities, we have sine 0, then here we have sine of sine inverse 2x, and here we have sine pi by 2. So taking the sine function of these three quantities in order to get rid of this sine inverse function. So sine 0 is 0 and sine pi by 2 is equal to 1. So here we have 0, and then we have here simply 2x, because from the properties of inverse trigonometric functions we know that sine of sine inverse theta is equal to theta, and here we have 1. So now we have this inequality 2x greater than or equal to 0 but less than or equal to 1. So now dividing throughout by 2, we have 0 over 2, then we have 2x over 2, here we have half, so this is 0, and here we have x, and here we have half, right? So the domain of this function, that is square root of sine inverse 2x, is given by this interval, that is 0 to half, and it is closed from both the ends, that is 0 and half are also included.